records the purchases at a fast food outlet shows that 63% of the customer buy a burger. The figure is made up of 30% who buy a beef burger, 24% buy a fish burger, and 9% who buy a chicken burger. No one buys more than one. Okay, so find the probability that in a random sample of 27 customers that at least 23 buy a burger. So if you're talking about, like the probability that someone buy a burger, so we actually look at the whole question in general. There are a lot of probabilities, so the one that we should be looking at is this one, because 23 actually buy a burger. So 27 customers, 23 buy a burger. So here you should be able to come up with the fact that we're actually looking at a binomial distribution. Alright, so for example, if you just let X, it means there are two outcomes, either you buy or don't buy. Alright, what is N? Let N will actually be 27. Let X be the number. Okay, so X will be the number of customers out of 27 who buy a burger. X will take on the binomial distribution of 27. And the probability of getting a burger is 0.63. Okay, so the probability of getting 0.63. So I want at least 23 to buy a burger, right? This actually just means that, if I take 1, I can minus it. Because if you use CDF, it has to be a less than inequality. So it's probably X less than equals to 22. And over here, just use your GC. Right, take binom, CDF, and 27, 0.63, and 22. Right, and your answer should come out to be 0.0108. This is for part 1. Okay, so next one, at least less than 11 customers do not buy a burger. So again, there are a lot of probabilities. So let's look at less than 11 customers but do not buy a burger. We can think a lot of ways to do what we can do. Of course, one method is we are looking at part 2. We can also say we do not buy a burger. We can say that if less than 11, less than 11 do not buy a burger, we can also say that this is the same of, if you want to think about the complement, it's the same. If less than 11 customers do not buy a burger, so we can also think about one method is we can say that we think about the complement of this. We can think about the complement of this. Number 1, we can say, less than 11 customers do not buy. So do not buy, the opposite is I buy. Correct? 11, what's the opposite? The opposite is 27, 11, so it should be 60 customers. Right? Because I buy a burger. Because it's either I don't buy no more than 1, so it's either I buy or don't buy. Less than 11 customers, what's the opposite of less than, or the complement? It means more than, right? So what's the probability that more than 16 customers buy a burger? So it's like the probability of X more than 16 buy a burger. This is the same as the probability of X greater than equals to 17, right? So because we don't include, it's the same as 1 minus the probability of X less than equals to 16. Alright, so all you need to do is if you go to your calculator and you say, I want to find the X, take on the binomial distribution again of 27 and 0.63. I want to find the probability that there's more than 16 who buy a burger. It's the same as finding probability of X greater than equals to 17. Alright, it's the same as 1 minus the probability of X. So this part to this part has to be very careful. A lot of people will just jump. Alright, so probability X less than equals to 16. Right, some people will actually, the careless one will actually jump from here. They'll go and write this, and then this will be wrong. This will be wrong. Alright, and with that, your answer will just come out to be 0.5868, 0.587. Alright, alternatively, you can say maybe I let X prime, this is method 1. Method 2 is you can say I let X prime be the number of customers who do not buy a burger. Who do not buy a burger. Okay, then after that, the X prime, right, since it's also follow a binomial distribution of 27 people. Now this is the probability that buy, right? So the probability I don't buy will just be 1 minus 0.63, which is 0.67. Alright, and I want X prime to be less than 11. So it's the same as wanting X prime to be less than equals to 10. And this will just be, again, 0.587. Right, so all I need to do is, again, using a GC, binomial CDF, 27, 0.37, and 10. Right, this is for part 2. So for part 3, I want to find more than 15 customers who buy either a beef or a chicken burger. Alright, so what is the probability that I buy either a beef or a chicken burger? So first of all, we need to look at the probability of buying a beef or chicken burger. So there's a probability of buying a beef or chicken. So if we just let, for example, let B represent I buy a beef burger, so you can do it by, right? C represent I buy a chicken burger, right? So this is like the probability of B union C, right? B or C. So some of you still don't know what's the difference between or and. Okay, so union means or, can take either one, so it's the union. Okay, so with that, B union C, beef or chicken. Okay, so B, this is just the probability of B plus the probability of C minus the probability of B intersect C. Alright, so what's the probability of B intersect C? Now think about it. This means there's someone who's buying both a beef and a chicken, right? But can it happen? Now think for a while. Can it happen? Cannot, right? Why cannot? Because no one buys more than one burger. No one buys more than one burger. So basically, if no one buys more than one burger, there cannot be anyone who buy a beef and a chicken at the same time. So this is just equals to 0. So basically, right, you can see actually the probability of B union C is just the probability of B plus the probability of C. Okay, and you get your answer to be 0.39. So if I now, okay, now I know that the probability of one customer buying a beef or the chicken is 0.39, I can now form a binomial distribution again. Okay, and Y will be the number of customers out of 27 who buy either a beef or chicken burger. So it's a B union C. So you take a binomial distribution again out of 27 people, and the probability is 0.39. With that, okay, I just want to find that I want to check more than 15 customers. So I want basically one Y, I want my Y to be more than 15. This is the same as, you know, probability of Y, I want it to be, so I always be very careful, greater than equals 16. Alright, this is the same as 1 minus the probability of Y less than equals to 15. Alright, so I'll leave you to think this through. Okay, I'll leave you to think this through because it's very important that you do not mix up the inequalities and you get the correct one. A lot of people write the wrong one and say, you know, they can remember that when you do binomial CDF, when you do binomial CDF, it's always a less than equals to, okay? It always includes the equal sign. Alright, then this is for part 3. For part 4, not less, do not buy a burger. Not less than 8. You can think about this into it. Number one, you can also use the complement. Do not buy. You think about the complement. That means I buy. Yeah. 8. What's the opposite of 8? That means it could be 27, right? So if I take, so it could be 19. 27 minus 8 is 19. The complement is 19. Not less. That means could be what? Not less means what? The opposite is just less. So less. Right, so less. Okay, not less means what? Not less. The score that I get is not less than 3. If it's not less, okay, it's not less than 3. That means what? It's not. It could be 3, right? Okay. could be 3, could be 4, so it will be at most 19. Okay, so there are a lot of ways to look at it. So number one, I can say that let x prime, again take the binomial distribution. X is the number of people who don't buy a burger. Okay, this can be one way. Okay, not less than 8 who do not buy a burger, who do not buy. So not less than 8 means what? Does it include 8? Not less than 8. Not less than 8. So that means what? Could be 8, right? Greater than or equals to 8. It is not less than 8 means it can be 8, can be 9, can be 10. This is what it means in English. So this again is just 1 minus the probability of x less than 7, which is 0.839. Okay, so here again use binomial CDF, binom CDF 27, 0.37, and 7. Okay, if I think about the reverse, not less than 8, not less than 8, this means what? Not less, the complement is at most 8, the complement is 19, 27 minus 8. Do not buy means I buy. I can also say is that the probability that at most 19 buy. Okay, I go to my calculator, I'll get the same thing, 0.839. Okay, so this part is a bit tricky because of the not less part. So please do think about it. Exactly 4 buy a chicken burger, given that fewer than 6 customers given buy a chicken burger. Exactly 4 buy, given that fewer than 6 buy. So this is the probability that exactly 4 buy chicken, given that 6 fewer than 6 buy chicken. Okay, alright, so again we take, maybe just let this be something, maybe let it be R B, right, so that it's easy for us to write it out present it in the solution. Alright, so R will follow a binomial distribution of 27, and chicken burger will be 0.09. Then the probability that I'm going to get R equals to 4, I buy exactly 4, and fewer than 6, and fewer than 6 customers buy a chicken burger exactly 4, by intersecting with fewer than 6 buy. So if I want an event that satisfies this, you think about it. Okay, so this is, again, I want this to be probability of exactly 4 buy chicken, and less than 6 buy chicken. If you think about this probability, okay, buy fewer than 6 buy chicken, you think about this probability, the top part is just probability of exactly 4. Okay, this is the probability of R equals to 4. Because I want 4, I can only buy 4 chicken, and I also want less than 6 to buy. That means what? That means actually the intersection is just 4. So this this is just 4. A intersect B is probability of A. They actually nothing. Okay, so the probability of A intersect B is just the probability of A. Okay, this is like, A is inside here and B is outside. Okay, this is just a probability that your R is equals to 4. And the bottom part, fewer than 6 bar, is the same as R less than or equals to 5. Alright, and use your GC for this, use your GC for this, you should get 0.136. Alright, so again, let me stress on this part, the fact that exactly 4 buy chicken and then less than 6 buy chicken, you combine these two events, that means it's just exactly 4. I need 4 to buy, I need less than 6 to buy. If the less than 6 has to be true and 4 chicken has to be true, that means the overall outcome is that I can only have one event that can satisfy both. That's only 4 buy chicken. Okay, then the below part, fewer than 6 buy chicken means 5 or less. Okay.